Welcome back to Within Tolerance podcast, the podcast for machinists by machinists. I'm your host, Dylan Jackson from Protean Machining, and this week I'm joined by Jonathan Hornell-Kennedy of Coreprint Patterns. So, welcome, Jonathan.
Thanks for having me.
So, let's jump right into it. How did you get into machining? How did you get to where you are now? I know you've got a whole lot that you're doing as far as mechanical engineering as well, and a wide range of things. So, go back as far as you want and kind of give us your story
How far back?
as far
uh,
back as you want.
I'd say like playing with Lego as a kid, if that's how far back you want to go. Those are some of the formative memories I have from like age below 7 of like using your hands to interact with the world, having kind of an end objective in the form of, what the picture looks like on the outside of the box, and then having to follow through a bunch of steps to get there. So what I used to do is like look at the final product and see if I could do it without following the instructions. And then you'd often back yourself into a corner. And I think that's where the mentality for machining comes from. Like often you're given a drawing or a part or something you have to make, and you know what steps are at or tools are at your disposal to get there. But sometimes you head down a path and you end up at no more forks in the road.
I think we've all been there for sure.
Yeah. So, and that I would say is like where I first experienced what, business knobs will talk about, like that state of flow, or being in like focused on your task and sort of the rest of the world fades away, like whether you get that writing an exam or whatever task you might be doing. So I experienced that with Lego, and then high school for me, I was an all right student, nothing special, and the schools that I went to didn't really offer anything hands-on. So I would say that I was a bit lost for a while in terms of, being told, here's what you should do. Not like my parents were ever telling me, you've got to be this type of career or anything. They were very supportive of anything that I would have wanted to do. But there just weren't like a lot of options for, like school didn't have shop class or anything like that. So did the university route. Some people on Instagram, I'm assuming most of the people listening to this know us via Instagram. So I've got some personal interaction with quite a few people. So some people might know all this, and I apologize for repeating myself, but my background is actually in statistics. So I have an undergrad and master's degree in a slightly esoteric field of statistics called quantitative finance or financial modeling or financial engineering, depending on who you talk to. So that deals with financial markets and time series. So I was sort of headed down the Canadian version of Wall Street type job.
Oh, okay.
Never really got there. So our Wall Street is called Bay Street. It's in Toronto. And so my educational background sort of groomed me for that type of job. And my heart just wasn't in it. Like I put the suit on, go take a couple interviews and things like that, and I kind of just wasn't vibing on it. So my dad is a mechanical engineer by education, and he owns and operates a business that deals with pumps, so industrial pumps. And I kind of finished school, my undergrad, right at the financial meltdown, 2008.
Oh, geez.
So wrong education for that industry. So went back into my master's, and then after that, I kind of cooked professionally. I know some people wonder about the whole cooking thing. Like we've got a separate cooking page, and I'm often posting food even on our main account. So I have cooked in restaurants, and so when I was done my master's, kind of doing a bit of that, but went to my dad's shop, which is in Hamilton. I wasn't living in Hamilton at the time, but that's where our current shop is, and kind of hanging out there, helping them out a bit. They do a lot of reverse engineering of castings. So their main business segment is either refurbishing or recreating pumps that you can no longer buy. Like a typical industrial pump could last as long as 100 years in service, right? And the chance of that company still being around to either give you replacement parts or, fix your pump are pretty low. So they were doing a lot of their reverse engineering manually at that time. And he kind of knew that like 3D modeling was required. So that would have been about 8 years ago now. So not like it was new then, but they weren't doing it. So I kind of said, yeah, hey, let me have a look at SolidWorks. So I went to like the SolidWorks resellers often have like courses you can take. You know,
Mhm.
like they might do like, I think I took like a 1 week intensive advanced part modeling class through Javelin, who's our reseller. And sort of, really, really crudely learned the ropes of SolidWorks. And then we got a ferro arm. So that's, for people who aren't familiar, that's a type of kind of articulating arm CMM. Looks kind of like an industrial robot. So it's got like encoders in each of the axes and either a laser or a stylus on the end of it. And it what we were using it for there was basically directly sketching inside of SolidWorks using that physical artifact. So you would have some casting on the table in front of you, and you kind of align your CAD geometry to that part in the real world, and then start scanning it. So say you had like a simple round part, you would sketch a circle, and then instead of actually in SolidWorks, dimensioning a circle out, you can just start picking points, and it would do like a least squares and fit a circle to the points that you selected off of the real world component.
Oh, that's
So
neat. That's really
yeah,
cool.
so got them up and running on that, and then at that time I had still kind of lost, not really sure what was going on. Had a friend who was sort of doing the same thing. A few years my senior, had worked in who was a civil engineer by training and worked in mining, and he was kind of ready for exploring some different options, and kind of asked my dad for advice on being self-employed and what that looks like. And Stefan is also a pretty hands-on guy, and so my dad, in running his business, requires foundry tooling like patterns, which is one of our main business segments. And at the time, he was saying, well, look, we buy patterns, and what I'm noticing of pattern makers is that they're kind of an aging population, and it doesn't seem like there's a lot of young people entering that space or, kind of pushing technical innovation within that space. Stefan, why don't you take a look at that? And I'm kind of there on the sidelines with the CAD skills and an interest in making things. So we started in a little 800 square foot shop. Stefan had enough money to buy the first machine, which is like a 4x8 industrial router. Because a lot of the foundry tooling is just made from wood or plastic, so you don't need anything crazy expensive or robust to cut it.
And
And
that's the one you still have, right?
yeah, it's still here, man. That thing doesn't owe us anything.
That's
it,
awesome.
it's a cool machine to have learned on. And the funny thing about cutting wood and plastic that often gets painted is you can make a lot of mistakes and literally fill them with Bondo and remachine it.
Yeah,
So
I
it,
wish I could do that with some of my parts sometimes.
yeah, so like I didn't get on Instagram until probably like 4 years after working. So anyways, I'll get back to the story, but
Yeah.
so yeah, Stefan and I ran the business for a year together, and then it was the classic small business, not enough business or work for two people who both want to be doing it. So we ran into some frictions, and that was probably like one of the hardest parts of my, maybe even my overall life. The couple months surrounding sort of the dissolving of our partnership, and believing in the business, working with a friend, but having the challenges of like, not necessarily that we wanted to run it differently from one another, but there just wasn't enough space for two of us, and I felt like I wanted to be there pretty badly. I'm sure he did too, and it just was not a good place for both of us to be. So I ended up buying him out. Like the first year, I worked complete sweat equity, didn't pull a salary. My Elise was not my wife at the time; she's my current wife and business partner. Um, she supported me for that first year till the business started making money. We kind of said like, we'll just pay back all the startup cost out of revenue, and then call it, like we each own a half. So he gave me an amazing opportunity in that, and So that kind of dissolved. I bought them out and ran it for about, I think, 2 years, kind of fully on my own, with some bookkeeping help from Elise. And then that would have taken us to about the time that we moved to the new shop, which is just about 5 years ago, which is, they're right around the corner from each other, but just a lot more space that we're in now. And at that point, Elise kind of came on more or less full time. Like, she still had some employment elsewhere, but I kind of went full turkey or cold turkey from the start, like no outside support, no nothing. So other than her helping me. So that was a bit of a grind. So those couple of years where I wasn't on Instagram and kind of working by myself, I put in a lot of hours, kind of getting confident with modeling the requirements of foundry tooling for our customer base, and running what is a basic machine, but in a lot of ways, nothing changes from the router to something that's worth a lot more money. And kind of learning the ins and outs and nuances of the tooling packages that we use. So I'm an HSM Works customer. But when you're 3D surfacing stuff and learning those things, and you make a mistake and you can just Bondo it up again, there's a lot of you can learn quickly without it costing a lot of money. So I would say not necessarily that they're mistakes, but the product we put out didn't suffer, because most people do that in our industry and paint the patterns at the end. So yeah, and then we've been in this space where I'm talking to you from for, I think, in the spring, coming up on 5 years.
And how big is your current shop? You said your first one was 800 square feet.
Yeah, it was tight, man. But it was a nice little setup. We just had the router in there and a couple other tools. But once you start getting into some bigger pattern builds, they take up a lot of square footage just assembling them. So that was cozy. Our current shop is 4,000 square feet. It's in some ways kind of an awkward layout. It's only 20 feet wide and like 200 feet long.
Oh, wow.
So yeah, it makes for, like, there's no way to set it up other than like a linear approach where most of our machines are down one side, and then it's kind of like a big hallway. But we've kind of got it divided up into a few different areas right now. So yeah, we've been here for 5 years, and part of the move was like the business was going well, and honestly, at that old shop with low overhead and a pretty modest machine, I think I was earning more money than I am now, just because our overhead is so much higher and we've got way bigger machines. But we kind of knew that we didn't want to cap out in an 800 square foot shop, making wooden patterns. So part of the move was we needed more space to operate, but also knew that we wanted more equipment in here. And it was really funny going from 800 square feet with our one machine that takes up like a 6 foot by 10 foot footprint, and putting it down in an empty 4,000 square foot shop that's basically a hallway felt like absolutely ridiculous. And we're getting to the point now where we're having to move shit around all the time because we're running out of space. So I don't think we're going to be moving anytime soon, but it's just it's nice to look back at. Sometimes you get caught up in the day to day and you kind of forget, can't see the forest for the trees type thing. But yeah, it's nice that we've got a lot of equipment in here now, and most of it's productive.
Yeah, so maybe that's a good point to tell us about, what your business name is, what you guys specialize in, and what kind of machinery you have.
Yeah, so the business name, we're just like, back when Stefan and I were starting, and just tried to come up with something, like, what do you call it? There's not really too much meaning to the name, other than people who know foundry tooling will know that the Coreprint is just a part of a design feature of a tool. So we started with doing, without getting like too technical into the foundry jargon, but doing floor molding tooling. So floor molding is a type of foundry process where they're making the sand molds, usually manually or semi-manually on the floor of the foundry. So a tool that we would ship them would either be in a self-contained flask that they just put sand into, and then once the sand hardens, they script the pattern out, and then you've got your sand mold into which the liquid metal will eventually flow. Or we might even send just like a loose pattern, so like the 3D form that they're going to put in their own box and pack their sand around it and do all the stuff from there. So we started doing that type of work, and those are the like kind of larger wood forms that I was discussing earlier. The challenge there is that that type of work in North America is it still definitely exists, and there's places that are quite good at it. But usually, those type of castings, when done here, aren't high volume parts. You know, the customer might want 1, 10, 100 at most. So the capital cost associated with the tooling is often a place where they don't see benefits from investing in something really well made, because if the casting comes out a little wonky and you've got to spend a bit more time machining it or whatever, that's really not offset by the additional cost. So yeah, like we knew that we wanted to get into a type of tooling that people are willing to pay more for. So usually that means you're relying on that tooling either to make something really precise, or you're going to run it really hard, make a lot of castings. So if you can save little bits of money here or there by, you know, more accurate part or less cleanup work required, you'll pay more for a tool. So that's where we went from wooden and plastic tooling into metal. So there's other foundry processes that are more automated, that require the tooling needs to be more robust for two reasons. One, accuracy, and the other is just that it's, you know, some of these parts might make 500,000 castings a year, and each cycle that's having sand packed on it, which is to a degree abrasive, and they get handled like beat up pretty badly at the foundries and stuff. So the next machine we bought after the router was the Mazak, it's a VTC 300C. So there's a style of pattern called a match plate, which is where the patterns are kind of mounted onto often like a piece of Mike 6 or some other precision flat plate, where the cope and drag parts of the mold are kind of opposing each other on this plate. And it goes into a machine where it molds simultaneously both halves of the mold, and then swings that plate out of the way and reassembles the mold and puts it down a conveyor line. So there are known dimensions for these match plates. Like the equipment that runs them is somewhat standardized, kind of like you'd have like a 40-20 table on your VMC or whatever.
Mm-hmm.
So I bought the biggest machine we could afford to try to shoehorn the match plates into. So most shops are running, you know, like a Haas or something in the 40-20 range for your typical PMC, but we've got 30 in the y-axis on this machine. And that allows us to do in a single setup some larger match plate work that some of the shops around here don't necessarily have as easy a time doing. And the other thing, the reason I chose this particular machine, other than like Mazak was one of the only people who would take it seriously at the time, is it's a traveling column machine. So what that means is the table doesn't move at all, so I can hang pretty big parts out of it without a risk of collision. So
Oh,
sometimes when I'm
nice.
doing like when I'm doing bigger plate work, I'll have to spin it 180 degrees to hit both sides of it. But I can kind of hang it out the doors of the machine without, you know, needing to check anything. The whole column moves behind. So
Yeah.
the Mazak we had for like pretty much since we moved in, so it's almost 5 years old. Have paid it off in September of this year.
Nice.
Yeah. So that'll be two machines that we own outright, which will be nice. So yeah, that one's on finance. So is the Matsura, which we have now. Sorry, I'm skipping machines. We bought a Brother R650 X1, the dual pallet Speedio.
Mm-hmm. Yeah,
And
I've got some questions about that later, both
yeah,
from
for sure.
listeners and because I'm a big Speedio nerd. So,
Yeah, so we just back to like we're kind of mixing topics here, and it's a slow story telling the narrative of the business, but it kind of makes sense to go down this path. So we're dealing with foundries, making tools for them to pour castings, and in order to do that, we've got to machine some pretty complex parts, and so a lot of these foundries require machining on their castings. So in an effort to kind of offer more services and to diversify our business a bit, we went to all our existing foundry customers and said, hey, you trust us to machine pattern tooling for you. Would you be willing to let us quote on machining your castings too? It was a pretty easy sell because people already trust you. And yeah, some of these places are pouring, you know, thousands of a part a week potentially. So, and often those things need subsequent operations performed on them, like most of your listeners are going to know that castings are not necessarily precision items from a machining kind of resolution. So the Speedio was a pretty natural fit for high volume 3-axis work on, I'm going to say, non-ferrous parts.
Mm-hmm.
Most of the foundries around us that are pouring that type of volume are non-ferrous, particularly aluminum. So that was a pretty good machine. So we had a couple projects lined up for that particular machine. I kind of knew it existed from, just I do a lot of research on, like I'm sure all machinists do, kind of following what models are being made by what manufacturers, what their relative merits are. So I knew of that machine. I knew a couple guys on Instagram running Speedios, like the 750 or 700. What's the
Yeah, the
kind of
700. That's what
yeah
we've got.
yeah. So they're being used. I think they offer like pretty exceptional value for the quality of machine. And so, anyways, we purchased that machine with a couple projects lined up for it, and I would say I think we had that machine on our floor for maybe 3 years. Over that 2 or 3 years, not a single project panned out for it.
Oh,
Um,
jeez.
yeah, that's sort of been the story of the business all along. Is like you go down one path and think that it's gonna work out, and I would describe it sort of like a game of whack-a-mole, right? Like we got this opportunity, we pursue it, learn all sorts of lessons. It grows you as a business. But then after 6 months or whatever, it's not really adding any revenue to your business. So yeah, like we can maybe, if it's of interest, talk through some of the parts, but maybe not now. Of like all these projects we had lined up, we pursue them, go through qualifying them with the customer. Yeah, they like the parts, or some of them were like literally 2 years of back and forth on, we don't like this, we don't like that. So you go back, redesign the fixtures, reprogram it. All
So were
this.
these parts that you designed all the tooling for as well?
We have one or two projects that we've done like full turnkeys on. So someone would come to us with a design, and we'd say we're going to walk you through designing the part for manufacturing via casting. We're going to build the tooling for the appropriate foundry process, and then we are going to machine those parts for you and deliver finished product. A lot of the parts that we're bidding on are existing components, often that our customers had existing machine shops working on, but either didn't like the service they were offering or the price or whatever it might be. So
Gotcha.
I
Gotcha.
went
Okay.
with the Speedio because there's some of these parts that we were doing, there's just not a better machine on the marketplace for it. Like we were doing one part that was, I think we were charging $1.65 for it, and that included 3 or 4 milling operations, 2 drilling operations, tapping, and like a little chamfer deburr. And we were, I think, when we had the machine going, and this is a big distinction to make for high production machining. When it was going, we were making like $350 an hour on it.
Whoa.
Yeah,
Jeez.
on $1.65 part, because the Speedio was just so fast. We had 4 on the table at a time, and the limiting factor on it was the operator being able to load and unload the fixture, and not the machine itself. Like I actually dialed back some of the, like, just for tool life, dialed back a lot of the operations like tapping and stuff. So, but the thing that is important about that is that that's while the machine's running, and it's, the person steps away for 5 minutes to go to the washroom. That's downtime. You're moving crates of these I think there's some photos on our account of like, we would have these tote bins show up full of castings, like 30 at a time, and they'd take up most of our shop. So
Yeah. Yeah.
there's some logistics involved with it. So when you're running through the numbers and you look, wow, this is making us a lot of money. Turns out that it might not be. And so what happened with most of these projects is people had given us sort of their historic volumes that they were running,
Hmm.
and perhaps sometimes embellished.
Oh.
So yeah, it got to the point where we're going like, okay, we spent all this time jumping through hoops to get the PPAP approvals done on these parts. Where's the work? And it kind of didn't materialize in a manner that warranted the monthly payment on that machine. So, and kind of concurrent with that is we were bidding on a lot of products that really benefited from multi-axis work. Like most castings don't have only a 3-axis machining operation on them, right? They need to be hit from different angles. So while we're kind of struggling through all these parts, we're bidding more and more that aren't truly a good fit for the Speedio, and that they need a horizontal to do them. So that's where we added the Matsura H plus 300. So it's a 300 millimeter pallet, but it pretty much specs out at everyone else's 400 in terms of travel. I think it's 20 by 20 in the XY. And so that machine allowed us to bid more competitively on casting work, where on the Brother we would have had to do it in 2 or 3 ops. So, and it's a multi-pallet machine. I think it's got five pallets on it. So some of the work we just had to say to our customers, look, the volume isn't there like you told us it was, and there were no hard feelings at all. They kind of didn't have any orders anyway. So the true 3-axis parts, kind of, we're not doing them anymore. And then anything that was on the Brother, we kind of moved it over to the Matsura, and we sold the Brother to a local company guy who's on Instagram as well, Modus Fire Rescue.
Oh, cool.
Yeah, they make, so they're like I don't know, 10-15 minutes away. So they got a screaming deal on the machine. I don't know if they know how good a deal they got, but it got us out of a position that didn't make any business sense for us. Like it felt like a little bit of a failure to have purchased a machine and kind of not see it through to fruition in terms of paying it off. But we were able to fully get out of that financing agreement. We didn't take a haircut on the machine, but I think we left a lot of equity in it. But it was the right business decision for us at the time, not having any work for it. And where that machine was now houses a pretty big injection molding machine and clean room. So it's
Yeah, so
kind of
that's
like,
your most recent edition, right?
yeah, technically we don't own that machine. It's a joint project with the local hospital network and university. We're trying to produce some lab components for COVID testing.
Okay, so that's part of that whole project, because I remember, watching you polish these. I don't remember what kind of aluminum tooling plate they were, but those little riser things that I think Adam the machinist worked on a few of them.
Yeah, so Adam did help us out with that. They that first project is still on the go. We're only one small aspect of it, making the plastic parts. There's a couple other components in the works with other companies and institutions. So I haven't been posting much about that because nothing's been going on really. We're building another mold right now to be running on that machine for another type of lab supply. These are all polypropylene consumables that are used in labs that are doing like the virus testing. So obviously there's a world shortage, or huge, I would say a huge demand increase, which has resulted in a world shortage of a lot of these medical testing components for biological labware. So that's what the inject. And so like, yeah, the week that the Brother moved over to Paul's shop, we that injection molding machine came. So it kind of all worked out for the better. But there was like, having done that, there were a lot of really good lessons learned about how to bid production work, what it looks like, how to design and build fixtures, how to program for high volume work. So I wouldn't change anything. It got to a point where I wouldn't say there was any ill will by any of our customers. They were just saying, here's what we typically see. And it was just a confluence of every single job just had low demand for the year or two that we had the machine here set up to go. So yeah, but that was a great machine. Like Elise and I both love that machine. So it's good to know that it's in a great home and we can visit it anytime we want. So I'm trying to think. Paul owns a couple robo drills as well, and they're older, and I'm just telling him like, man, you got to put every single product you make on that Speedio, clear out some floor space, and start doing it. So Yeah, so the most recent CNC machine purchase was the Matsura, and we've had that for a little over 2 years now, I think. And then yeah, the molding machine is here, with the intent that we're running it on behalf of sort of the province to make parts. So I'm hoping within the next few weeks to be done the next injection mold and kind of go from there.
Awesome. Yeah, it's been a cool journey watching you guys get that running on your stories and stuff, because I know it's not plug and play. Like, you had to make a lot of parts and sort a lot of things out, and it was cool. That's like such a part of the world that I'm not a part of, and so it's been really interesting seeing all that happen.
Yeah, I appreciate that. Like you kind of are a part of it, though. It's pretty much everything you touch is probably injection molded, right?
Oh,
Like
totally.
there's,
In my day
yeah,
job, we do a majority cast work.
yeah,
So we do a lot of the machining kind of stuff that you're talking about, and so I deeply know the struggles of trying to do all of these what should be 4-axis parts on a 3-axis, because we've got a few 4-axis machines, but a lot of it is products from the 50s that were engineered in the 80s to just run a million ops on a bunch of different machines so that they could do it that way. So I know it.
yeah. Like a well-designed casting and manufacturing process is. There are some, you're right, heritage drawings, I'll call them, that go back a ways. But if you've got a component from a company that had good engineering competence, it's pretty remarkable to see what they could pull off back then when like you're struggling to do it with CAD and like high-end machine tools with probing and stuff, and these guys could have pulled it off on manual machines. It's kind of cool. Um, but yeah, so like to kind of recap on the services we offer, we're a tooling shop that predominantly works in foundry. So we deal with sand, investment casting, permanent mold. So those are the three kind of main foundry processes. You either pour your liquid metal into a mold that's made of sand, or a refractory that was made in the lost wax or investment casting process. So that was sort of the segue into injection molding. Like we kind of stuck our neck out saying to the local university and hospital, like, yeah, we'll help you out on this. We've got some reverse engineering competence and we can make molds. Um, so it's been a bit of a learning curve for us too to transition from what is wax to a plastic part. So the molds that we make for investment casting, they shoot a liquid wax into it. So that's why most of the time they're just made out of aluminum. No crazy tool steels required because the wax is very forgiving. And that foundry process, what they do is they make a wax duplicate of the component to be cast, and then they dip that in like a ceramic shell. So over the course of a few days, typically it's dunked into like a slurry and then coated in a refractory sand, like maybe a zircon or something like that, and they build up this crust around the wax. And when that crust is of sufficient thickness, they put that whole thing in a kiln, usually a burnout oven first, but then a kiln. So what happens is the wax that's inside that shell that was creating the negative space of the part you want melts out, and you're left with the hollow shell that you can fill with liquid metal whose internal geometry is exactly the part.
Makes
So
sense. It's kind of like those wax hands you get at like Renaissance fairs, things like
yeah,
that.
yeah, yeah. It's like, well, like I think wax casting is like the OG, like the original Bronze Era casting, right? Like all those sculptures and things like that were done that way. So I think maybe even before sand casting, investment casting was. Someone might need to correct me on that, but I'm pretty sure that was one of the first forms of casting. So yeah, that type of foundry tooling are technically injection molds, but typically they're manually operated. So what that means is the operator is sitting often in front of a horizontal press, so the platen's open, kind of like a die stamping machine. So it squeezes down on the tool just to clamp it shut. A nozzle will come over and shoot plastic in, and then after sufficient time has passed for that wax to change from a liquid to a solid, the operator slide the mold forward on the table and kind of manually take it apart and remove the wax and do that again. And then those are often assembled onto what are called trees. So that's multiple pattern impressions being put on the same, like a down sprue, so that
Hmm.
you can pour multiple parts at one time. So that's the foundry tooling. Then we do machining of castings for our customers, and now some injection molding work. So it's kind of it covers a lot of things. We cut a lot of different materials, which can be challenging at times, just from like a shop management standpoint. Like having tooling set up that I've got to strip down to move from aluminum to H13 or whatever. But um,
Totally. Well, and
I would.
castings in general are not easy. I think there's fewer and fewer shops that are willing to deal with them.
Well, and that was kind of one of our angles when we're going to our customers, saying like there's not too many places that understand castings better than a pattern shop. So let us quote the machining, and maybe we can offer you a competitive advantage. And yeah, so that's worked out on the products that we're still doing, where the work is there. So yeah, there's, like you said, there's some challenges with how do you hold them. No two castings are the same. That
Nope.
that also introduces when you're doing thousands of them in a batch, you've got to make sure you accommodate for that. So depending, and often they're not particularly high value parts um, when they're done in that quantity, and they're small non-ferrous castings. So you've got to hit a certain price point uh, to keep it competitive.
Totally. And they're always trying to beat you down every year for a little bit more too. So
You know what? I think, yeah, we have some customers that are like that, but for the most part, if you're offering a good value proposition, people aren't trying to squeeze you too hard. Like you
that's
said,
good.
there are limits to how many shops can handle that type of work. So if you're willing to do it and do it well, I think there's a certain respect that you get for, um, you know, offering a service that if they want to squeeze you too hard, they might not have any luck finding someone elsewhere that can do it.
Totally. Well, that's great. Okay, so that's the name, and they can find you. Coreprintpatterns.com is your website. Coreprint Patterns on Instagram as well, right?
Yeah, yeah. Like I don't know that we do the best job posting on Instagram. I've sort of been mostly in stories, and I'll be honest. Sometimes I post something thinking like, "Oh my god, this is so cool," and like it flops. And then other things, I get so much feedback from people, and I never would have expected it. So it's kind of cool to see like that drilling machine that we're working on. That's just kind of like a little joke project in a way. I just didn't want to make a fixture to put those parts on the Matsura twice. So instead I built that machine, and I haven't gotten more like DMs about a project maybe ever.
Yeah, so
So
this is a great time to go down that route. So for anybody who hasn't seen it, if you go to his stories, you guys are making a pretty much just a one axis drilling machine on linear rails to drill some casting. So let's kind of talk about the mentality of why not make a nice fixture for your Metsura for it, lessons learned, all that stuff. What's going on with that?
it's working well. Like we got our first batch of castings in to run through it. I think the drills aren't lasting. So the backstory is there's a casting that we do where the majority of the work is done on a horizontal tombstone on the Matsura, and we were doing a secondary op on the Brother Speedio to drill these three small little holes. They hold a name tag, like one of those rivet-on machine tags,
Hmm.
and one of the holes is like for one end of a spring to go into. So they're not particularly critical, but they're long and they're going into a cast surface and they're pretty small diameter. So the Speedio was an incredible machine for it. We spot drilled, and then there's two different drill diameters. But once we sold out, this is one of the projects that we have on the go pretty steadily. We knew we had to come up with a solution for drilling those holes in the top of the part that's off axis from like it would be pointing up when you're on the tombstone. So you can't hit it in the same operation. So we looked at like a multi-spindle drill kind of thing, but the problem is the pitch spacing between the holes is really tight. So I think for me, it was the lesser of two evils, in that I found the drilling machine way more interesting to do than to build another fixture, which is basically the exact same fixture we had, just twisted 90 degrees, right?
Right.
And you know the machine can drill the hole. So a bit of it was like, can we do it? And the other thing is we wouldn't have to load the machine twice. So we've got it set up in a manner where while the Matsura is processing 12 parts on the tombstone, the operator can be loading that manual drilling fixture, and they kind of match each other well. It's almost like it was meant to be. It's within a couple seconds. So
Oh wow, that's
yeah, yeah, it works out well. So yeah, this little machine, the operator loads the casting into it, and there's three drills all driven by the same motor. Obviously positioned right where the holes are meant to be on the casting, and the pneumatic cylinder just feeds the parts in to the drills, and once the drills break through, it hits a depth stop and then kind of retracts. So
So when I was watching you build this, I was like, how are you guys preventing the drills from just bearing into the material under the pneumatic pressure? Because that was the one thing that I must have missed in one of your stories.
there's a regulator on the cylinder. So it's fed with our shop air or whatever that is, 120 psi. But then what I did was the big problem with the design is I think the drills are only spinning at about 6,000 RPM. And I think on the Speedio, we had them at 16,000, like whatever the max spindle speed was. They're
Right.
small drills. There's like 80 thou, 90 thou, I think. And they're going pretty deep. So on the Speedio, we were pecking, and you know how well that machine does that.
Hmm.
So right now I'm spinning them at whatever 6,000 RPM. I think I've got a 2-to-1 gearing ratio, and the motor, I don't know if I can trust the name tag on it. It's our Canadian Harbor Freight equivalent buffer motor. So who knows if it's lying to me or not. So yeah, what I did was basically just keep adding pressure on this regulator until it was creeping at a rate where the drills weren't gumming up.
Okay.
Because it can't peck drill, it's got to do the whole shot, like the whole hole in one shot.
Right.
So yeah, it takes about 35 to 40 seconds to drill through. I think it's about somewhere between a half inch and 3/4 of an inch through this part in like A356, which is the cast equivalent of 6061.
Yep.
And you'll like it's interesting. You'll notice a difference between even within a single batch, the varying heat treat that might be on the parts. Like some will fly through it in like 20 seconds, and other will take that full 40 seconds to get through on,
It's
back to,
relatively abrasive too. I've found in our
yeah,
machining.
definitely the oxide layer that's on the outside of it will be. So yeah, they're a OSG drill, the XSUS. I don't know if I'm saying that right.
Hmm.
Gold drills. So yeah, 3 millimeter shank. And they've been pretty good for dealing with gummy materials if you can't get a like coolant through drill. So yeah, they're running on that machine, but that I only brought that up because it's an example of like you don't really know what the Instagram community is going to respond to. I think some of the stuff we do is a little esoteric, and that's why sometimes my stories are really long. I feel like you've got to kind of get a certain amount of information through for it to even be meaningful. Like I know you had Renzetti on, and he was talking about how he likes to do these like super super content rich. Every single word out of his mouth is meaningful. Um, and
Yeah, description is in the audio. This
yeah. Like
is go to.
it's tough for us to do that, right? And there's an element of we can't share some of the work we're doing, whether that be for confidentiality reasons or like we're controlled goods certified, which is like the Canadian ITAR.
Hmm.
So that stuff, like technically, when that stuff's in the shop, we don't have anything here, but like we're checking IDs at the door and things like that. So
Yeah, you got to make sure who's a citizen, that kind of stuff.
for
We do that
yeah,
work too.
like yeah, we're supposed to be recording. We haven't had a project come through that's required that level of clearance, but yeah, Elise is the person on staff who's allowed to handle those documents and that type of stuff. So yeah, like we can't have Instagram at the shop all the time, and I think the cell phone that I use day to day is not my iPhone that I have Instagram on. So that's why I'll go sometimes, a week at a time without posting anything because I got to get work done. And I know that as all the benefits of Instagram sometimes are weighed down by like the distraction to your workflow. So I'll leave the phone at home.
Oh,
And
definitely. Yeah,
yeah,
yeah. And you guys are a small shop. I mean, it's just two of you, right?
yeah, right now it's just two of us. So when we had the brother here and we're doing more higher volume, like the one thing about that I'll come back to on the machining of castings is that's something that's pretty scalable. So we saw that as a really a potential way to grow the business. You do all the hard work one time programming, building the fixtures, and if you do a good job, it's easy to employ someone to run the machine. They don't even have to be a machinist. So whereas a lot of the tooling work we do, it's a heavy amount of design that goes into it. Like I probably spend 40 hours a week in CAD. That doesn't show up on Instagram because it's boring as hell. But like everything we make, we typically design. So it's not like a typical machine shop where a customer is sending you the exact part they want. You just have to figure out how to make it. We have to figure out how to make the thing that makes the part. And that's usually our obligation and what we're being paid to do in terms of designing tooling. So um, that each project is good and they're profitable but it's just really hard to scale that work without having a ton of people who are equally passionate about the design side of things and skilled at it. So we're production machining. There are a couple of big shops near us that are at least North American leaders in processing of cast parts. So they'll have rows and rows and rows of CNC machines and like a single CNC machinist on staff where the operators, if they get like 3 parts through the no-go gauges that fail in a row, they call the guy down from the office and he troubleshoots it. So that was a bit of our inspiration for moving to that type of work where we could offer employment for people and not need someone with a huge depth of knowledge and a really specific skill set. So we had some people who were helping run that machine when we had a lot of work for it. And when the work left, they were part-time and there were no hard feelings there. They were kind of semi-retired people who were helping us out. But so right now it's just Elise and I here.
Yeah, yeah. So you got to be protective of your time spent for sure. And Instagram can definitely be a big time suck.
Well, yes and no. Like it's not so bad to pick up the phone every once in a while, but like when I'm building these injection molds, one little lapse of judgment can set you back like a month or two's worth of work. So it's just like precarious workflow. I want to minimize the amount of potential room for mistakes. So if I know I've got a day, like the other thing is if I know I'm not going to post anything because I'm doing repetitive work, there's not really an advantage. Like I do want to take Robin's kind of approach of I don't post every single thing we're doing if I don't think it's going to be of interest to people or offer a little bit of value to someone who's interested.
Yeah, that totally makes sense. And you've got your cooking channel to keep you busy too.
Yeah, we did that at the start of the first lockdown. What is that? Almost a year ago now. Just when everyone's holed up at home, not knowing what to do. So yeah, Elise and I are both pretty into food. You got to eat 3 meals a day. So why not get into it?
Yeah, no, it's
Uh,
been cool. I think I think because of lockdown and COVID, there's been a lot of machinists posting, hashtag machinists that cook and what they're doing while they're at home and stuff like that. So it's been interesting to see.
yeah, our hope with that was just to kind of offer some sort of recipe inspiration to people, or here's how you can do something at home with pretty minimal ingredients. So yeah, we like. There's a lot of days where we're doing takeout or pretty boring dinners. Again, like pasta 3 nights a week, just because that's all we got time for. So, not posting that every time we make it because I don't. People will be going like, "What's with these people?"
Totally, yeah.
all they eat is pasta.
So we've got a few questions from listeners that I wanted to run by you as well. Split 141 on Instagram asked, "What do you use for scanning, and do you have any recommendations for a good scanner for individual automotive parts?"
Yeah, so we don't own in-house any 3D scanner right now, but I would say the FarrowArm, the one that I helped my dad's company set up, that's a pretty good product. I think Romer makes an equivalent. I guess the question I would need to be able to ask him is or her, I don't know, um,
Him, yeah.
what level of resolution or accuracy are you looking to scan at? What software are you using? Like so many times, these scanners are more dependent on the software you're running behind them, which can be pretty expensive. Like the real advantage of the FarrowArm, we were only running it with the stylus on the end of it. So you really had to know how to model the component well. You weren't getting a point cloud of data that you kind of fit something to. It was just like a really accurate sketching tool. So I think there's a product called EinScan,
Yeah.
EINSCAN, that's pretty good. Depending on again, like you're not going to be measuring any like bearing fits or stuff like that, but it's going to be plus or minus 5 or 10 thou on a scan surface, and the meshing on that software is pretty good. Like I think Geomagic is what you've got to step up to if you want to be dealing with like big point clouds. And that I don't even know what that license costs, like 50 or 60 grand, I think, just for
Jeez.
the software. Yeah, so the Faro arm, you can do point, like single point. So you got different stylus tips you can put on it. There's a laser attachment, so you can do that. You know, like spray painting your part, so to speak.
Hmm.
Ion scan, I don't know if it's stratified light or what system it uses. I don't think it's laser. You've got to put those little reflective dots on your part.
Right. Do you have any
Uh,
experience with the Creaform scanners? I know they.
yeah, I was going to get there. So I think they're a Canadian company, actually.
Yeah. Well, I know they have the lower end one, the Peel 3D and Peel 3D 2 now that I've been looking at. I only mention them because I've been looking into 3D scanners just as kind of a hobby thing. Like both Brad and I, my business partner, are big automotive geeks, so being able to make our own parts and scan them would be amazing down the road.
Yeah, like I think the ion scan would be a better. Like Creaform's expensive. You're in like the six-figure range, I think, to get into the whole bar and so they offer a few different products. I think some of them require those stickers to be put on the part everywhere, and others have like a base station kind of thing you set up behind. So it's got
Hmm.
these stereo scanners, and then they've got like the handheld CMM, which is works in conjunction with that, and then the laser scanner. Um, Really good product, really good software integration. A perfect example of like you get what you pay for. It's high end stuff, and it the price is commensurate with that. But I think it's a good product. Like we demoed it, had the guys come to the shop, and we went over some parts. And yeah, like I think what I really liked about that is it could automatically, like if you got a point cloud, you scan, say, I don't know, auto like some intake or a turbocharger or something like that. It would You could set up like a slicing profile, and it would automatically slice that point cloud and then give you like a 2D sketch at some lofting interval.
Oh wow, that's
Yeah,
awesome.
output into like a SolidWorks. So, but again, I think they might have run like I think it's Geomagic in the background.
Okay.
So yeah, the 3D scanning, I would just stick with those one of those import things to learn. Like you can often like use more traditional metrology equipment to measure anything that really matters, and then with those kind of free form shapes, you fill in the detail between those critical things that you measured. You know, like
Gotcha.
you're gonna measure your engine block or whatever for where the intake manifold fits on it. You could probably do that pretty well with a pair of calipers, and then the rest of that shape, if you're going to have any collisions with the rest of the stuff in your engine bay, you can scan for that and kind of nestle them together in the same CAD file.
Yeah, that makes sense. You use the tools you know for the really tight stuff, and then yeah, fill in anything that you can't really freeform measure with calipers.
Yeah.
Yeah, that totally makes sense.
So yeah, like
Um,
I just just the iron
oh,
scan
go
I
for it.
think is great value. Like if you want to start somewhere, I don't know what they cost right now. The Iron Scan Pro I think is under like $5,000. Is that
Yeah,
right?
I think so. One of my customers has one, and he seems to really like it. I know last we talked, he was still kind of getting used to it, but
Yeah,
besides
and
that,
I'm pretty sure it comes with its own software that can deal with the point clouds. So
yeah,
that's not
which sounds like it's really the crux of it.
it can be absolutely, and but like I think Geomagic is independent of the actual scanning hardware. So they offer like a point cloud for whatever you want to be scanning with, whether it's Faro, Romer. Um, I'm sure some of the higher end machines like the Zeiss that you can do 3D scanning on, you have your choice of software to run that information through after you collect it.
Right. Yeah, that makes sense.
Yeah, but like you don't have to pay extra with the iron scan is my point. And
Yeah.
from what I've seen, like the first hand, like one of those plastic parts that we're working on, reverse engineering, we scanned, like I took a plug off of the internals with like a two-part polyurethane and scanned that to get the internal geometry, and it checked out pretty well.
Oh,
Like
really?
within a few thou, and then yeah.
That's really cool. All right. So Danny Rudolph wrote in and said, "What are shift locks and why are they so great?"
Yeah, so for anyone who doesn't know, Danny used to work in the foundry world. Um,
So he was one of our like first Instagram followers, and we often have a dialogue going back and forth about casting related things. He worked at a foundry as a process engineer, I think. He'll have to correct me on that. So yeah, shift locks are like what align the two halves of the mold, and we're having a laugh about that because so often castings have issues associated with them. And to use his language, a knee-jerk reaction for a lot of misalignment in castings is that there isn't enough shift lock. So when you have your two halves of the mold in foundry jargon, they're called the drag, which is on the bottom, and the cope on the top. You have to have something usually to stop them from moving around relative to one another. So chain lock is it's like a bunch of dimples that go between the two halves. Like if you've ever seen like fiberglass guys make a mold or something like that, or silicone rubber molds done, they put like a male impression, and then when they pour the female part of that, you get like an interlock. So that same thing happens in all of the foundry tooling we build has to have some form of aligning the cope and drag halves of the mold. But when you pour a casting, you might get like you deal with castings, you'll see like parting line shift or things like that, where one half of the part isn't aligned with the other, and that's a result of typically the mold moving. And so when you observe that, you go, well, hey, we don't have enough mold alignment, so let's add more. But so often that part shift isn't actually caused by not insufficient mold lock. You could have an instance where the hydrostatic pressure of the metal actually like lifts the cope off the drag and it sets down somewhere else, and that's why you've got the shift. So
Oh, really?
oh yeah, for sure. If you don't have enough weight on top of the mold, that can occur. So like Danny's joke is that might actually be what's going on, and instead of fixing that problem, they just add more chain lock to the pattern. So he's making fun of me because we had a part where the customer basically said add as much chain lock as you can to it, and I was posting about it, not complaining or anything, just saying like putting a ton of chain lock to try and prevent this. But yeah, so there can be a host of issues. Often it's actually like mold swell that's causing that. So certain areas of the mold might be too thin to support the pressure of the liquid metal, and they'll actually push out of the way a bit, depending on the foundry process. Like the molds have a certain level of compliance built into them if they're a green sand mold. Like if you push hard enough, you can break it. So liquid can push kind of very evenly and bow things out. So you'll end up with what looks like parting line shift, but really it's just the mold kind of distorting with liquid metal coming into it. So yeah, that would be an instance where they solve that problem with parting line shift, but the problem doesn't go away.
Oh, wow. Yeah, there's so many things that I guess that can go wrong with the casting or the casting process that I would have thought of. That's really interesting.
Yeah, it's something that's been done for a long time. Casting, it's something that's even to this day not particularly well understood from a like super intense predictive modeling kind of. There's a lot of things that happen when you're casting. You're dealing with turbulent flow typically, which is a complex enough problem to solve on its own. You're dealing with temperature modeling. So the whole point of a casting is that you take a liquid metal and you're getting a solid metal out in a specific shape, but it has to kind of change phases from a liquid to a solid, and the way it does that is by losing temperature. So a lot of people hate on castings for being kind of crappy quality compared to forgings or billets or whatever, but most people don't acknowledge that every single piece of metal starts life as a casting. You know,
Yeah, right.
it
No,
just happens. It just happens to be in an extremely simple and well-controlled foundry process. So when you're doing like continuous casting and pouring billets, you can really control how the metal flows and how it's cooling in that process. And in doing so, you guarantee really good material properties.
totally. So speaking of that, and actually getting to one of Tom Machinist's questions, he asked, "Are you using NX to program your machines?" But you mentioned that you use HSM Works. What software packages do you use? Like we had Brian Denola from Autodesk on 2 weeks ago, and he was talking about mold flow analysis software. Like, do you use anything like that? What do you guys use for CAD? What do you guys use for CAM? All that stuff.
Yeah, so I'm in SolidWorks 99% of the time, and I use HSM for programming because pretty much everything we're doing is still 3-axis work. On the horizontal is positioning, and then 3-axis from there. We have NX and CATIA. not like outright license ownership, but we've like rent them basically. And that's to do some of the aerospace work that's natively modeled in CATIA. And
Oh, okay.
yeah. And NX, we got to deal with that CATIA data. Yeah, the sort of short story there is cut my teeth in SolidWorks, but I've always kind of known that it's not the best tool for the job, especially in some of the complex geometries we deal with. And for a long time, I kind of had NX as like, that'll be my, you know, I've made it when I can afford an NX license and the work to warrant that. And so we finally got some aerospace work and got NX, and it just totally shit the bed on what we were trying to do with it.
Really?
Yeah, I think the reason for that is that the underlying part was modeled in CATIA. So coming back to like, we have to change. We got to design everything we make. Often we actually have to change the incoming part geometry considerably. Like, it's pretty remarkable how many parts we have to work with that have no draft on them, despite that being a clear requirement for
Yeah.
pretty much any molding process, right? So they just say add draft, and it's like, well, okay, that's can be really complex to do for something that has a parting line that kind of undulates everywhere, a ton of cores, all this
Yeah.
type of thing. So the other thing you have to do is what you put into the casting process might not be what you get out. So you have to kind of push and pull geometry in certain directions if you have a good sense of how it might shrink or move when the part goes from liquid to solid. So in this particular instance, we needed to make a bunch of those changes to this geometry, and I thought, like, I know SolidWorks isn't going to be capable of doing this. I'll get an X, it should be fine. And it literally couldn't do a single thing. Like, I think SolidWorks and NX are both based on the Parasolid kernel, like XT. So
I think so too. I'm not 100% sure either.
yeah, like SolidWorks licenses a ton of stuff from Siemens to run in the background. So every place where SolidWorks would have hung up, NX also hung up. They just give you a few more powerful tools to try and problem solve that stuff, and it wasn't doing it for us. So I still think it is a more capable product than SolidWorks, but since it couldn't do the few, like, I'm calling them simple, but they're not simple, the few finite tasks we needed done, it couldn't do. So to me, it wasn't worth the learning curve of a new CAM system and modeling. Like, a huge thing for us is that because we're making so many changes to the parts and programming them, we need to be in the same environment for both modeling and programming. So that's one of our huge decision-making criteria. Is if I had to export into a different CAM package every time, I wouldn't get anything done.
Yeah.
Like, like a given day, I might post 200 or 300 programs to one of the CNC machines while I'm making a tool. Like,
oh wow.
Yeah, like everything's on the network. No USB walking over, anything like that. The Matsura is actually my least favorite machine because I've got to use that FANUC file transfer software, where the other controllers are all Windows based. So I actually have my post processor set up to just like dump the file right onto the drive. Like, I don't have to do anything.
Oh, that's awesome. So then do you just use like a one toolpath workflow where you're like, okay, I'll do this section or this toolpath and let it run while I finish programming? Because I know a lot of people are starting to move towards that to just keep the spindle running if you've got long run times.
Absolutely. But I'd say I take it even like a more reckless step farther than that. Is like, we're not done designing the tool when I'm cutting it. Like this injection
Oh,
mold I'm working
geez.
on. Yeah. So I've got to be able to like change the geometry pretty heavily while we're already in production. Like the injection mold I'm cutting right now, I'm kind of working from the bottom up, but I'm still haven't finished designing the top half of the tool. And because that's all done in the same parent file, I can't be exporting that stuff, trying to do revision tracking, all that. So yeah, absolutely. A lot of it is like on the, because we're dealing with complex 3D geometry and you don't often know how the tool paths are going to perform or behave. I take like, you leave a bit of stock, basically run what's your finishing pass, just with some stock remaining, see how it behaves, and then work your way to the final geometry. So
Okay.
it's almost like I'm carving away with, finite tool paths approaching that geometry. So often it'll be a testing. So I'll post something, see how it runs. And then, basically I have to iterate that over and over again as I creep up on the geometry.
And you
Uh,
ran into that this week, didn't you? You were having a bunch of chatter and random pockets in what you were machining.
Yeah, so that, like, I have some gripes with HSM Works, the toolpaths they generate, especially on the roughing, where some of the linking moves, it may be totally above board and it's doing within the, like, I don't know if I just have to like crank the tolerance to, 50 millionths on everything and hope that all the linking moves come out super accurately. A lot of what we do, I am dealing with really long gauge lengths on the tools, um, approaching 10 to 15 times D.
Oh, geez.
Yeah, and so a tiny, 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 like, to what any normal machining operation would be an imperceptible amount of variation in tool engagement has catastrophic effects at that length. So yeah, the issues we're running into is those pockets are, I think 1 3/4 inches deep, and I'm going down there with a 1/4 inch ball mill.
Oh,
So, you hit the tiniest little bit of, I don't know if it's material differences within the pockets or any tiny little linking move where it's going to want to bring that tool slightly closer to the material. The second you get regenerative chatter, that end mill either snaps clean off or it gouges the part really badly. So yeah, like on the first night I was running that part, we at least came in the morning and there's no tool in the tool holder. And
oh
it was
no.
well, the shitty thing is it actually snapped off in one of those pockets in the lead in move, uh, but continued the pocket clearing operation. So when I got there in the morning, I thought, like, that's weird. The end mill's stuffed in that hole, and it's kind of stuck in there. And I didn't look that closely, but it turns out that it had ground the whole face of the tool holder down on the back.
Oh, jeez.
Yeah, not much, like, I don't know, 50 thou deep. But I guess what it was doing was just kind of like rolling that end mill around in the pocket, because once it broke off, it had nowhere to go. So
Oh,
I
man.
tried to fix that part because there was still material remaining, and I did a cleanup pass, but it had like pushed the end mill into the aluminum below the part geometry. So yeah, stuff like that where there are software packages that you can simulate cutting force and things like that. Really, really high value CAM packages. But even then, I don't know at what level of accuracy they're going to be doing it. Like, your margin of error is so small there that I'm not sure if they're meaningful. Like, I think there's a couple plugins for Siemens and a couple other that'll model cutting forces.
Right.
So what they're doing and their kind of optimization of the post-processing is they'll say any cutting paths that don't meet a minimum requirement of cutting force, we're just going to remove from the machine code, because there's no need to go and clear material that isn't technically there, right?
Yeah, I was going back through your Instagram and somebody mentioned a few of those. You were talking about adaptive clearing and all the little whisper cuts you can get with
Yeah.
that. And
Yeah, so like, you watch there's a whole bunch of YouTube tutorials on, like, don't get your machine to air cut, change these couple parameters. Like, the problem with all the 3D contouring we do is there is technically cusps left there. It works very well for prismatic parts where you can say you've cleaned up all along that wall, but the second you add draft to that wall and you lean it back 1 to 5 degrees, no matter what level of clearing you did before, there's always going to be those theoretical little bits of material that the tessellation is going to find during, stock remaining after previous operations or whatever. So
definitely, yeah,
yeah, so that's where, like, I'll often use 3D surfacing toolpaths to do my final stages of roughing.
that makes
Uh,
sense. Yeah,
some of them you can say stock remaining, but you'll still run into that problem. But basically, I'll just start, in those deep pockets. At some point, I know I'm just going to go to a contouring toolpath with the bullnose end mill and step it down 10 or 5 thou at a time, and just know that I'm going to get consistent tool engagement no matter what's there.
makes
But
sense. Do you guys use a lot of high feed cutters then, or have you
um,
started to use them?
I love high feed cutters. I think, you'll know from dealing with castings, they don't hold up well there, not because of the material or hardness or anything, but you need to really control how much material is coming at them in Z depth, right?
Hmm.
So with a casting, we had some problems on the Speedio where customers would leave like a gate witness or something really high, and a face mill that can take like a 10 millimeter depth of cut, or 10 or 11 millimeter we'd hit the holder body into the casting.
Oh, jeez.
Right. So yeah, they're aluminum castings, not that big a deal, and they shift in the fixture. But so those are ones where we'd have to probe the top of the casting first. So high feed is like that on steroids. You need to make sure you're only giving it whatever 10 or 15 thou depth of cut. So yeah, we use high feed cutters, but predominantly for the harder materials. I don't know of a high feed tool that's designed for aluminum.
I don't either. Yeah,
Yeah.
I've actually looked for them for the same reason, for long reach stuff.
Yeah, like you can get away with a bullnose cutter. I think there are a couple companies that make inserted tooling. Like I think the ideal cutter for the type of stuff we're doing would be a bullnose or high feed geometry. And just as you come around the cusp of the tool is relieved backwards. So even if you're up against the wall, you're only cutting at the kind of outer bottom corner of the tool, if that makes sense.
Yeah, definitely.
So like,
So maybe you can talk to us. You have a ton of experience. Like your tooling has to be, perfect surface finish, or as good as you can get it at super long reaches. Are there any lessons of the trade that you can share with us as far as getting the best finishes out of like insane 10x plus reaches?
I don't know that I'm an expert on that. I think buy the most expensive machine you can afford and put the best tooling into it. There's no way around that. Like, so yeah, I'll sort of qualify that statement a bit. Is that a lot of pattern shops hand finish stuff, and even if it's made out of wood, they'll take like 100 thou step over, and then a guy will go at it for a full day with a sander. And I never wanted to do that. I'd way rather let the machine run overnight and program while that machine's running than spend hand time benching. So we took the same approach when we moved into metal tooling, of just try to get the best surface finish. Like our customers expect a certain level of surface finish. I hope that we exceed it often. But the main thing is I don't want to be doing that work manually. So I'd way rather have the CNC machine do it.
Totally. Yeah. So like, have you found any, I guess, rules of thumb, like, taking a certain depth of cut, or
No.
lower RPM, higher feed, anything like that you found really exceptionally improves tool life and finish?
No, there's no real easy answer. Like each case, each geometry is going to be giving you specific hardships. Like that, to go back to that little mold insert you're talking about, yeah, that's one where I looked at it and thought, this shouldn't be that hard. That wasn't actually the part of the thing that was concerning to me when I started machining it. There's some really thin ribs that I still have to machine out of those that I thought was going to be hard. So light cuts and high spindle RPM if you're cutting a material that'll allow you to do that. So aluminum, there's pretty much no ceiling on SFM. You can feed it, right? Like your RPM on your spindle is going to max out. But one thing that we have a few of our air turbine spindles.
Oh, okay.
So a lot of the pattern work we do has like lettering or things like that cast into the parts. Like the part number code might be on the side of it, and so we basically have to 3D carve text into surfaces. So we got the spindle speeder to do that. We're doing like a match plate that had 20 or 30 different parts on it, like duplicates of the same part, but the mold would produce 30 castings, and they were filled with text. And so I've got 12,000 RPM on the Mazak and I think 15 on the Matsura. And we've got to use sometimes like 1/64th ball mills to do that. So I knew there was no practical manner of getting that done with that spindle speed. So yeah, I think they're 40 or 50,000 RPM that they'll do. And we drive them through through tool air. So they just tool change like a normal tool.
Mm-hmm.
And yeah, when I'm doing long, like those are tiny tools, but you're still running into the same aspect ratio problem that you're asking about, right? Like diameter to length stick out. So I'll program those sometimes at like a 3/10 step down.
Oh wow.
Yeah. But because they're spinning at 40 or 50,000 RPM, you can feed a really tiny tool at a reasonable feed rate. So,
That's cool.
yeah,
That's
like
really cool.
I think with long stick out tools, you really want to control, you don't want to surprise that tool with anything, right? Whether it be a jerky motion or a little bit more material than it's expecting to see. So that's where what I'll do in my workflow is basically 3D surface the whole part as if it was finished, but with material remaining. So that'll let you see where any potential errors are. And hopefully you've left enough material on your part that should there be errors, you can still clean it up. And you kind of learn lessons with every single part geometry in doing that. So we probably cut everything 2 or 3 times more than it technically needs to be, but you don't know that it's going to work right the first time. So, like we're not trying to maximize or optimize cutting time on a lot of the tooling work we do. It's more the value is in actually producing the part and getting it done well, and not doing that in 8 hours instead of 9. So
Yeah,
yeah,
that makes sense. So
the
what's
lot.
your approach then on quoting these parts if you know you're going to be cutting them?
Yeah, that's a
Like
tough
a
question.
lot of us is, just like we roughly program it or figure it out in your head, and it's just time plus materials plus whatever overhead or whatever. But for you guys, I mean, you might. It seems like you go into it knowing you're going to have to cut it a few times and that you're going to have problems. So how do you guys go about that?
It's hard, right? Like we do a really wide array of work, and yeah, if I were to sit down and try and do the calculations you're talking about on a big tooling job, it would take me like a week to quote it accurately. That's not the right word, quote it accurately. To know for sure that that's exactly down to the cent what it's going to be. With foundry tooling, there's like anything else, there's sort of a market price on average, but you could see wide variation. So like we quote a lot of work. I probably do historically, 10 or 20 quotes a week. But each one of our foundry customers is going to probably 3 or 4 other pattern shops to quote that work. And often they're transparent about what other people are charging. So within reason, unless it's an exceptionally complex job, you kind of just have done enough of it that this is what the market will bear for this type of work. And if you think you can do it for that price, then have at it. So yeah, like there's you can predict pretty accurately what your material costs are going to be. Your work envelope is defined. You know how much you've got to buy. And then, yeah, the other aspect is the design time, right? Like you didn't ask about that, but that's a huge portion of what we're doing. Some customers are very specific about what they want. Others kind of leave it up to you, and you're on the hook. So you also need to factor in things like how confident are you that your initial design of the tooling will even work, let alone can you make it that first time.
So on
So yeah,
average, how many times do you guys go back and forth to get
on the
what they
design
want?
or on reworking.
I guess both.
The design, it really depends on the customers. Like Foundry is not necessarily the most forward-looking industry. Like it's like foundries are tough businesses to run in North America. There's a lot of environmental pressure on them. It's hard to get people who want to work in foundries, and the price pressure from outside of North America is almost insurmountable. So a lot of these places aren't. They're not at the bleeding edge of technology. Like we've had some people where if I email them something, I get a fax back where they've printed out my email, right? So it's your back and forth will depend greatly on the internal engineering capabilities of the foundry you're dealing with. Some have multiple engineers on staff. Others, the guy who runs the foundry is the guy, and he just says, make it for me this way. So that depends greatly based on the customer and sort of what their expectations are. So at the design phase, usually they'll, like at quoting, they'll tell you roughly you need to build the tools for this type of process. So you have a sense there. But then, yeah, certain very demanding customers will have, like, you'll submit, your first round of design, they'll say, here are the things that we want changed. You go back, and sometimes that will take a few days, or sometimes it will take months. So yeah, that's the type of boring stuff that we're not really showing on Instagram because,
Right.
you know,
Well, and how much leeway do you have? Because you were saying, you've got customers that bring you models that don't have any draft. Like, how do you know how much you can modify something before you're going to screw up their tolerances, or is that just part of the back and forth?
some of it's part of the back and forth. There might be an element of ask for forgiveness, not permission. You know, like you do. Like I'm still pretty young in our career, and I'm going to say like we've got a whole lifetime of experience, but you know what's going to work and what isn't, and at the end of the day, if the person's happy with the casting, sometimes it's not worth asking for permission on every little thing you're going to do. But you've got to be okay with dealing with fallout if it doesn't work out. So yeah, like often the customers with that level of knowledge of their own process, they're going to be telling you those things, and they're not going to come back on you if it doesn't work out. You know, at the end of the day, everyone's got to make money. Our customers do that by selling castings, and they can't sell castings without getting foundry tooling at a reasonable price. So it's in everyone's best interest that it works out the first time. So
Yeah.
yeah, we don't do a ton of rework. I think we kind of pride ourselves on that, like do our best to get it right the first time. That helps lead time. It helps keep the cost down. And the biggest hurdle we have to overcome is it's really hard to break into new foundries. Like most foundries are really set in their ways, and because of all the things you've noted about how complex some of these tool designs and build outs get, it's really hard to onboard new suppliers, right? Like it would take, a lot of these people, the foundry and pattern shop are right around the corner from one another, and Larry and Joe have been working together their whole lives. So they just know what works. They don't have to have that back and forth dialogue. So when we come in as a new vendor, people will say, yep, seen it before. We've seen new vendors, never works out. Get out of here, pretty much.
Right.
So, yeah, part of it is you just have to be willing to stick your neck out there and make it work. But there are also a lot of kind of cut and dry jobs. Not everything has to be complex, and those are, it kind of is time and material in a way. Like there's not a ton of modeling work in it. It's a simple geometry. You know exactly what that customer requires for their foundry process, and you go from there.
Yeah.
So I don't know if that answers your question well or not. Like it's a pretty much, it's like, yeah, you just know what the market's willing to bear, and hopefully that you can come in under that and still make money.
Definitely. So another one of Tom Machinist's questions was, how did you get into the idea to cast straight edges? And so that might be a good time to bring up Coreprint castings.
You do your homework, eh?
A little bit.
Yeah, that was just sort of like, I think I sent one of the first ones we made to Tom Lipton as sort of like an appreciation. I watch a lot of YouTube content. That's sort of how I learned everything. I'm self-taught. So, they were, it was back in their scraping phase, whatever, before it got to the lapping phase. However many years ago that was, I thought, like, yeah, there are people who are saying, the Richard King scraping classes. I signed up to go to one of those, and it didn't happen. But from my own end, it didn't happen. I couldn't make it to John Saunders' place.
Mm-hmm.
But yeah, there's people have been saying we can't buy these things. There used to be a couple companies that make it. So I thought, hey, why not? Like, we don't make any money on selling those things. It's pretty much like we're just passing them along, but it's sort of a community engagement type thing. So yeah, there's a couple different geometries on there, supplied, some of them in different lengths. And yeah, we're always open to make other geometries. I get a lot of questions about camelbacks and things like that. I really want to do a cast iron surface plate, kind of like the Moore design, where it's
that'd be cool.
Yeah, like a fully ribbed torsion box, so it's not hollow in the back. It's like two full skins with webbing in between. But again, it's like those hobby projects. There's never the time or budget to do them, right? So if someone's really serious about a camelback, we can make them a pattern, but I pretty much have to roll that into the cost of selling them that first casting.
Right. Yeah, that makes sense. So
Yeah, like
what about the other? I've seen on your Instagram you have like cast iron skillets, and I thought I saw a wok at some point. Are these customer projects, or is this also internal projects?
though there's no wok, maybe the big fire pits.
Oh, that's what I'm thinking of. Yeah, yeah, yeah.
Yeah, so the fire pits were someone, a family member asked us, you've got a machine shop, so people ask you all sorts of things. Interested in a fire pit, like one of those, like I think probably plasma cut, with their whatever pine trees or some bears or something around the side of it, And I thought, I don't like that design, but I deal with castings, not plate work. So what do you think of this? And that pattern was actually made of styrofoam, like white EPS styrofoam. And the way it got made was we were looking at having for some of the larger volume stuff before we bought the Mazak, we looked at having a KUKA robot with the spindle on it. Like
Oh, cool.
I think there's a really good account on Instagram, Robotic Solutions. I think they're a really good integrator of milling with a robot. So there was a local integrator that looked at helping us do that, and as a test piece, we had them cut that styrofoam pattern, which takes no time at all. You basically go to finished dimension and just rip through it, and you don't need to worry too much about step over because there's only so much that styrofoam can hold, right? Like it's
Right.
gonna grain apart. So those castings, yeah, we probably made 10 or so of them, and it's every time we make them, people ask like, "Oh my God, that's so great, that fire pit! I want to buy it." And then you tell them what it costs, and it's like I think the castings themselves cost us like $400 or $500.
Oh,
They're
geez.
big. They weigh like 180 pounds. It's I think about a 40-inch diameter fire pit. It's just a bowl shape with some legs on it. But yeah, the frying pans, the cast iron frying pans that's a project that Elise is working on. It's a marketing thing for this customer. They are a marketing company, and Kraft Foods is one of their customers. So the promo is, the idea was that you get a frying pan that when you make your grilled cheese in it, it toasts the company logo on the.
Oh, okay.
Yeah, so it was some promo where like the 50 winners get a custom engraved pan, and they choose the artwork that goes on it. So it's for like
Cool.
craft singles, those like processed cheese slices.
Yeah, yeah, yeah. And so
So
you guys went from casting the names in them to machining them, correct?
yeah, we had a lot of challenges with the foundry being able to pour the text. So kind of coming back to our discussion of um, variability in the foundry process and the challenges that can arise there. Little things like the humidity on the day the stuff is poured, how the sand is behaving that day. That text can either show up well in the casting or it can be completely obliterated by the liquid metal. So we were having inconsistent results. Like aesthetically, we're not happy with the components. These are, unlike a lot of the more engineering focused work we do, this especially appearance matters with these things, right? It's kind of the only thing that matters. So when the text wasn't looking good, we kind of went back and forth with the foundry, tried pouring a couple different things, changing the gating, and just weren't getting the results we wanted. So that's when Elise decided, like, I'll just try basically engraving a toolpath right over where the text was supposed to be cast into them. And it worked well. So yeah, she's been picking through that. It's not so bad because we're engraving the names on the pans anyways. So they're set up in the machine.
Awesome.
Yeah. So
So one last kind of, I guess, pet project I've seen you do, and I saw the end of it, I don't think, was your chocolate bars.
good memory. Yeah, like the what would I say? The internal pressure of trying to make those work changes seasonally. The idea is that, so for anyone who doesn't know, the idea, Elise and I are brainstorming like what type of marketing gimmick can we send to people to kind of showcase your ability as a tool maker, right? So we made a mold that kind of cast a chocolate bar with our logo engraved into it, and the hope was that that would pretty fine detail in the chocolate might someone might look at that and go, hey, that's kind of cool, right? Like they can clearly machine something of relevance. Um, But every time that the weather starts to get warm out, we don't really want to send those things out in the mail, right? We don't want a melted chocolate bar showing up to someone. So it kind of, all through the summer months, we kind of forget about it. And then the winter comes back around. And so the big issue we're running into there is we're not good at tempering chocolate.
I don't
So
think anybody's good at tempering chocolate.
yeah, so we've tried a couple of different things, microwave, sous vide, all that stuff. I think what we need to do is make the mold out of something that has a lot more compliance than aluminum. And also, I think thermal properties, the grain structure in the chocolate, because you're chilling it so hard on aluminum substrate. I think most production chocolate molds are made out of like a form of plastic, whether that be HDPE or some other type of plastic that's not going to suck the heat out of the chocolate so much. So yeah, we made a silicone. Like I poured a plug into the mold we made out of like a 2-part polyurethane resin to basically make a duplicate of the chocolate bar, and then made a molding box around that and poured liquid silicone onto it, like a 2-part to make like a rubber mold. But the problem is we don't have a vacuum chamber, so that mold had a whole bunch of like inclusions right on the surface, like little air bubbles in the silicone. So yeah, and then it's like, with so many other things going on, it kind of falls to the wayside. We used all the silicone we had in that one shot, so I need to get a vacuum chamber and try that again. So that's where that's at. It hasn't gone away, but we always end up eating all the chocolate before we have the mold ready to go and pour another one. So yeah, like that's the backstory on it. Like trying to come up with some clever little marketing gimmick. Like you can only send out so many PDFs and like printouts. It's nice for someone to open something and maybe they like chocolate too.
Right, exactly. Yeah, if anything, they'll look over and be like, and think of you when they're eating the chocolate. So
Yeah,
that's really cool. So he had a couple questions about the brother, which we covered, but he wanted to know what your next machine is, and then do you miss cassoulet because he does.
So Tom's French for people who don't know that. So yeah, I speak a little bit of French, being from Canada, so that's where we have a good dialogue on Instagram about food-based things, especially French cuisine and machining. So yeah, I miss cassoulet, but we've got a couple good places we can buy French-made cassoulet around here that comes canned. So that, for those who don't know, it's a kind of a hearty bean and duck confit based dish that's good on a cold winter's night. So yeah, I missed a brother. That Elise and I both love that machine. Like I said, you've got one. They're
Yeah, I
pretty
love it.
bulletproof. Yeah, really cool machine. I don't know what the next machine is. Part of the problem is we do so many different things that there's no perfect machine for what we do, right? In kitchen jargon, it would be called like having a unitasker, like a machine that's really good at one specific type of thing.
Right.
Our biggest challenge on the tooling side is that we need a relatively large work envelope. So that puts you just into a cost bracket that is often prohibitive.
Right. Yeah. Because I would have thought like 5-axis would be good for those longer
100%.
reach things, but then you get into the work envelope issue.
Yeah. So like NX being sort of a goal of mine, a 5-axis machine is like, that's got to be on every machine owner's. Like, I've made it when I've got to 5-axis, right? Like, who doesn't feel that way? Who doesn't own a 5-axis? Like, that's when you made it to the big leagues. So yeah, like the challenge there is like, what kinematic structure do you go with for the 5-axis machine based on the work envelope? Like for a lot of the foundry tooling that we do, I think that new Haas gantry machine with the 5-axis head on it would be pretty perfect.
Right. Yeah, I was going to say some kind of mutating head is probably better suited to what you guys are doing.
Yeah, on the large things, but then you're going to run into, like, when you're trying to pull those really good surface finishes, your structure has to be repeatable, and it's like over a day's worth of work. Like even on the Mazak, before we had temperature control in the shop, it's really hard to do those really long cycle times and make sure that your machine's coming back to the same spot on like a 30 square inch work envelope throughout the day, right? Like the kinematic structure is going to shrink and grow and move with heat. So that's a consideration when you're trying to get really good surface finishes. If your cycle times are long and your machine's moving all over the place, you might not repeat as well as you think you're going to. So that would be one of my concerns with the big Haas machine, is that you're doing a ton of surfacing, and without linear scales or something on it, it might move around on you throughout the day. So when you go back to finish something that you've already machined, you might end up gouging the part. So yeah, like a dream machine for me is rotors. I don't think they get a lot of coverage. I don't know if you're familiar with them or not. German made.
Mm-mm.
Roeders, I think.
Oh, okay, yeah. I have seen that. You're right.
Yeah, so they're like, everyone knows about the other red machine that comes from Germany that's really precise, but somehow rotors flies under the radar, and I think they might be a more accurate machine. Not having any firsthand experience with either. But yeah, they've got all sorts of crazy stuff in them. Like, I'm pretty sure the servo drives on them are actually fiber optic because they had to make their own drives to be able to respond fast enough.
Oh
Yeah,
wow, that's insane.
yeah. They're like top notch. They're like very much like a Kern. They're meant to be like high end tool making, where they do grinding and milling on the same machine, potentially, if you want to spec it out that way. But unlike the Kern, they get into some pretty big work envelopes. Like, I think they do one with a 1 meter table on it. So
Jeez.
yeah, so that would be like a dream machine. I could talk about machines all day. I don't know if this is the right question to ask me, because like SIP,
Yeah.
another really nice brand, but that's high accuracy. Like, I would like to get one of those if we're doing more mold work, for the mold bases, things like that. But yeah, like, each sort of segment of work we're involved in has a machine that would be well suited for that style of work. So yeah, just a big 3-axis machine would still be very capable. So I don't know, another horizontal, like, I really like Okuma's MBH 5000. I think, is that the
Okay.
right part number? I think that's the like 30 by 30 stroke horizontal.
Yeah, I think that's um the one that the guys down in New Zealand have, Ignite Digi, or maybe they have the smaller one.
Yeah. Chris, is that his name?
Yeah, Chris Fox, I think.
Yeah. I don't know if they've got the 5 or the 4000.
I can't remember. They've
Yeah,
make
he looks
somewhat
pretty big.
smaller parts, so I would think that it would maybe be the 4000, but I
Yeah,
could
so
be
that would be
completely
like
wrong.
equivalent size to what we have, 20 by 20 travel. But yeah, I think that's about 30 by 30. So again, coming back to that match plate kind of footprint that I mentioned earlier, the billets that we need for the larger machine that gets run in our part of the world, the billet size is, I think, um, around 30 inches by 27 inches. So as long as I could put a slab of aluminum with that footprint on the machine and like get an end mill around the sides of it, that's pretty much all I need. Like, for us, the perfect machine is actually like square in terms of its travels, right? I don't know why they're always rectangles. If someone can answer that question, like, I never care about the x-axis, because that's not the constraining footprint for us on a 3-axis machine. It's always y.
Hmm.
So yeah, for like some of the foundry tooling where we're doing cutting more plastics and wood, yeah, big gantry router with a 5-axis head on it, I think, would be the dream machine. And then yeah, for cutting tooling work, there's a lot of, you can spend a lot of money pretty quickly specking out your dream machine for that. But yeah, definitely multi-axis. Will, if you can, like, a lot of the stuff we're doing, you can't fit. It doesn't matter that you can lean the part over, because you still can approach the part from that angle in a multi-axis setup, right? Like, huge deep pocketing, it doesn't matter if you can tilt the part over, because you're going to be hitting your end mill into the other side of the wall.
Right. Yeah, especially on some of those really deep and
Yeah.
narrow pockets that you've been posting.
So yeah, then you get into, well, do I need EDM, or do I need like a wire machine? I would like to have a sinker and a wire machine at some point, because there's tasks that we get into where that's the perfect machine for it, but you might have 10 applications of that a year, so
Yeah.
it doesn't warrant. Who couldn't fill out their garage with all sorts of dream machines if the budget was much?
Oh yeah, yeah. I would have only a garage, and I'd sleep next to my machines if I had my way. So I totally understand that.
Yeah, and the other thing is, like, in a lot of the foundry tooling work we do, I would say the market price of the goods sold really only supports like Haas level machines as being what you could afford. So when I look at some of those parts and say, yeah, it'd be nice to slap that on a big 5-axis machine, we'd never pay that machine off with that style of work.
Right. Right.
So sometimes you're up against what other people are willing to run and do their work on.
That makes
So,
sense. Yeah.
yeah, like injection molding, there's definitely there's more room for higher value machine tools because the tooling is really expensive. The tooling being like the product you're making.
Right. Right. Well, I guess so. Speaking of injection molds and castings, Windmill Motorsports asked, "What do you most enjoy about machining castings and complex injection molds?" And Obsidian Tools asked, "Experiences gained from machining lots of castings as efficiently as possible." So I guess let's talk about all that.
Yeah, those are, I'd say, two different questions. One about castings and one about making molds, right?
Yeah. Yeah.
Yeah.
Yeah.
Okay. So I'd say what I enjoy about machining castings is that we understand castings well based on designing and building tooling for them. They present their own host of challenges that is can be really satisfying when you overcome how to deal with them. I would say the ideal way to machine lots of castings well is with hydraulic work holding and having work supports that kind of compensate to the part. So I don't know if you're that familiar with hydraulic work holding, but often with castings, you'd support it on 3 main points to define your plane.
Hmm.
But then under critical areas, you can have these kind of spring-loaded work supports that will come up and touch the part. And then when the hydraulics turn on, they basically lock in that position.
That makes
So
sense. Yeah,
you're
like
not,
something from like Vectech or one of those
yeah,
companies.
you got it. So you're not inducing any stress in the component. Like you're still supporting it on its kinematic mounts, so to speak, like your 3-2-1 kind of work holding approach. But you're then supporting it where it needs rigidity um, to resist any of the machining forces. So yeah, like what can be satisfying about machining castings is when you're dealing with an engineer that really knows what they're doing. And again, I'd say the older the product line, the greater the likelihood of that because of the prevalence of castings as how kind of everything was made going back a certain time, right? Like as CNC machining has become more widespread, it's easy to make parts out of billet that historically never would have been done that way, right? So back in the day when all they knew was castings, they knew how to do it really well. So you'll receive documents or your drawings, your machining drawings should spec out how they want the thing to be located and held. So working on projects like that where the people really know what they're doing can be satisfying. But yeah, like it's what do you learn doing it? I mean, you'll look at a part and say, here's what I think is going to work, but I don't actually know. And you never know until you try it. So I think if you've got the need to machine castings, don't be scared to like totally scrap an idea and start over from scratch if it doesn't work out. So if you've got the ability to do so, I think like 3D printing a potential fixture and just seeing how that behaves, not actually running it in the machine if you don't think it's robust enough, or making it like, well, I'll make stuff out of wood sometimes, like just quickly run over to grab a bunch of scrap plywood from the waste bin and see if I can block something up with screws and wood glue that I think might work to hold the part. And then CAD, like if you've got good CAD of the casting, like a 3D model, and you're confident moving around whatever your modeling environment might be, that's a really powerful thing. Like a lot of times there's an old school 2D drawing of the part and you're handed the actual casting, but you don't have the CAD data that fully specifies the complexity of that component. So what you might have to do in that situation is make a really crude 3D model that represents just your machining envelope. So basically block out a prismatic part that has the same rough envelope of your casting, and then add all your machine features to it so you can program it and then figure out how you're going to hold it. So yeah, it's there's no one answer, I would say, for what's going to work for all castings. You kind of have to take each one. And the other thing that we'll look at often that other people might not is where potential sources of variation could come from in the future based on how the casting is made at the foundry. So usually when you're doing a job like this, you'll be sent some sample parts and you'll design your process around them. But that doesn't necessarily mean that the next batch of parts you're going to get look exactly like the sample parts that you were given when you built your fixtures, right? Like I've seen situations where they send you castings a month later and they don't even fit in your fixture.
Right. Yeah.
Yeah,
The
because
tooling wears, or they
no,
change
not so much
foundries.
that.
Or
Just like that could be a case. They move the castings to another foundry, or just even within a single foundry. Some guy might have forgot to grind a certain spot, or the sand was weak that day and they had some burn in, and it's not. So to know where all those sources of problems can come from, this may not be a helpful thing to say if you're not really experienced with castings, but to kind of predict what might go wrong in the future is a useful thing to look at when designing the fixture. Because like I said, just because your parts look a certain way one day doesn't mean they're going to with the next batch. And if you can design a process and a fixture that's robust enough to deal with that, you'll be in good shape. So the other question was about injection
what do you
molding.
enjoy about complex injection molds?
There are parts where I don't enjoy it at all because you're literally like pulling your hair out trying to get it to work. It's daunting. I think I like it. For me, really the most satisfying part of any tooling build is not building it, but seeing the parts that it makes at the end. Like if there's anyone out there listening who buys tools from someone and makes parts, send them a sample part if you can. It'll make their day. Like so often we'll ship a pattern out to a foundry and you only hear back from them if there's bad news. But it's really, really satisfying to see the casting that came off of the tooling you made. And in the same, it's kind of like a longer feedback loop of like, Dylan, I'm sure you still get joy out of, there's a part on my computer screen and I just pulled the real thing off of my machine. Like that's just cool.
Oh,
Getting to
totally.
make a part. So
Yeah.
when it comes to,
Or like you send it off to a customer and they send you a picture of it assembled, and
yeah,
you're like, oh,
exactly.
okay, it actually goes to something. It's not this arbitrary part number anymore.
Yeah, so that would be my most satisfying part of building an injection mold or a foundry tool is like, it sounds corny, but a happy customer. And usually a happy customer is a result of the part looking good when it comes out of the tool. So I would say actually seeing the tool run. We're lucky that a lot of our customers are local, so I'll go when the tool's being commissioned. I'll go for that, help troubleshoot, make sure everything's okay, and watch it run. So that's really satisfying to see like this thing that you might have spent half a year working on do what it's supposed to. And even when you've been doing it for a while, there's still that kind of pit in your stomach of, is it actually going to work? And sometimes a sense of disbelief when it does. You're like, no way. There's just so many things that could have gone wrong along the way to get there, and it works out. That's pretty cool. So
Yeah, that's awesome.
in the like, what machinist doesn't like precision fit on two parts they've made? I'd say that's pretty good. So if you want a more shorter time scale answer to what's fun about making injection molds is like you got to hit some pretty tight tolerances, and when the parts go together, that feels nice.
I bet. So another question we had from Yuri Ellison was about what prompted your decision and what it took to become AS 9100 and ISO certified, because that just happened this last September, if I remember right.
Yep, good memory. I think we were working like our final audits were in the summer, and then because of all the shit that's going on in the world, it took a little bit longer than normal. So I'd like to preface that by saying, like, can you think of a more shit time to get aerospace accredited than when the world literally tanks that industry?
Right.
So that certainly didn't prompt our decision to do that. It's something we've been working on for a while, and Elise really is the one who handled that. So I'm a little bit out of my depth here. Like we made the decision to do that together, but she handled it all. Like I sat through the audits and tried to have a smile on my face and not screw it up by saying the wrong thing. But
Right.
she really put in the legwork and made that happen. Actually, with one of Danny Rudolph's buddies. So Danny had his ISO, and I asked him like, who'd you use, and it was one of his college friends, I think.
Oh yeah, so he might actually come on the show at some point. I think Danny
Yeah,
said that he had
Adam Marsh,
interest.
I think is his name, if I remember.
Yeah, that sounds right.
Yeah. So he got us like we're in Canada, obviously, for anyone listening who doesn't know that. I don't know if we said that. And Danny's in Pennsylvania, and his buddy is too. So there's some limitations to what you can do cross border without paying for a lot of travel. So he kind of got the ball rolling for us, and then found a local auditor. So yeah, we got it. What would I say? We got it so that there's one less reason people couldn't give us work. Does that make
That makes
sense?
sense. Yeah, that totally makes sense.
How many places do you walk into and the first thing the procurement person asks is, "Are you ISO?" And it's like literally, it's just a cop out, like easy, like I don't want to deal with you, so we can just tell you to kick rocks if you don't have it.
Right. Well, and when you say that you are, they take your paperwork and just throw it in a filing cabinet, and it's
yeah. Well, to be fair, we're approved vendors for a lot of places that require ISO, despite not having had it.
right.
So there we have to do like annual audits because we don't have ISO, whereas now like Elise just gets to mail our certificate, and it's like nothing for her now, where before it was like days of paperwork and kind of like appeasing whatever quality control people they might have. So yeah, the impetus to get it was, it's kind of like you got your big boy britches on now, right? Like we're grown-ups.
Right. Well, I mean, it's like going to apply for a job and they ask you, do you have your master's or something? And you're like, no, but I can do this and this and this.
I read the
And
book.
Yeah, you got to prove yourself. But then once you have that piece of paper, they're like, okay, well, they're, sign off that thing. Good.
Yeah. So it was to help us grow the business, to try and get more business. And I think as of like a little more than a year ago, one of the biggest industries in our neck of the woods is aerospace. So when we're looking at around all these shops that are literally turning down work because they're so busy, we say like, well, we got to do what they're doing, and that's aerospace work.
Totally.
So we had a couple customers in mind, one of which we managed to land even despite the kind of downturn in the work that industry has seen. So I think the other thing that it will be good for is our intent is always to grow the business. And as we add more people, those kind of quality management systems become increasingly important. So yeah, that's sort of the main thing was, can it help be a tool to get more revenue in the door?
Okay. So what about what it took and lessons learned, I guess, from the process?
That you're going to have to have Elise on the podcast, I guess.
Okay.
Lessons learned, get a good auditor if you can, I think. So much, especially with such a small business, right? It's like nothing we do makes sense on paper when looked through that lens. I'm not saying we do things that are not congruent with ISO. It's just like it's a system that's really designed around big companies. And when
Right. Yeah. An MRB meeting or an NC system, when you're the one signing off all the boxes, seems a little silly.
Exactly. So, and some people want to be super literal about how they interpret the guidelines. So if you don't have an auditor that's sort of willing to recognize that you're a small business and look at the rules kind of through your lens, I could see it being very challenging. So I think one of the best things that Adam did for us was find a really good auditor.
Okay.
So yeah.
Were there any big changes to your workflow? I mean,
none at all.
Okay.
No, like we're such a small business that like it doesn't, like maybe I should say that a bit differently. There are certain things we have to do now that are more demanding from like quoting, especially on aerospace. So what we did to split it up was, if you're manufacturing parts that actually end up in an airplane, you got to really be careful with what you're doing. But because the type of stuff we're selling within that marketplace is tooling, it doesn't matter as much. That might not be the most smart choice of wording, but like we're making tools so that the other people can make parts that go on the airplanes.
Right. Yeah. Well, and like I've always found, like in AS, like they, did you do a risk assessment on this quote? And it's like,
Exactly.
yeah, I looked at the part and I'm like, I think I can do that. Like, I
Yeah.
mean, how much am I going to do?
Yeah, like your day job is AS.
Yeah, we're AS and ISO, and we actually do risk assessment meetings before it, but it's a big production. Like for my shop, if I got ISO and AS 9100, it's like, what risk assessment did I do on one part that's a prototype that they asked me to do? Like I looked at it and I said, yeah, it's good. Okay, let's go.
Yeah, like you're doing that mental calculus inside your head no matter what. You're not saying like yes to everything and then, oh shit, I couldn't do it. Like you're going to give it an honest appraisal. And so that's where like Elise and I, we run a business together. We, you know, when are we not talking about work? We're just not writing down the stuff we're doing, right? So if you want to use that, the risk assessment example, when we're doing quoting, like we'll talk through things. We would have done that before aerospace or ISO certification, but so now we just need to basically write down somewhere that we had that discussion or made those considerations ahead of time. So again, for our workflow, because everything we do is like we're like really, really pure job shopping in a sense, right? Like I only make one of one tool and that's it. That's not even like, other than the production machining of castings, which doesn't really fall into we're not doing any aerospace casting work. It's there's just like your workflow is different for every single job because the parts are different. At a super, super high level, we remove metal from parts, right? That's the same thing we do every day. But when you want to get drilled down to a specific job, like we don't have like the Kanban carts or anything. Like it just doesn't work for us because our tooling is different for every job, things like that. So there's some sort of standardization things that are still challenging for us to implement because the work we do isn't standardized, if that makes any sense. I don't know.
Oh no, it totally does. These are I would love to get AS and ISO certified. Just again, same reason as you, to break into those markets that I have trouble breaking into.
Yeah.
But it is those kind of questions that it's like, man, how am I supposed to do that when like that's not how my business is run, and that's not how like this style of business is run at this size. So it's refreshing to hear that you guys both have those issues and have found ways to get past them.
Yeah, like I think Elise's thing on the website was something like, our commitment to quality hasn't changed, but now it's official, or some cute line
Yeah,
like that. Like,
yeah.
we still like to put out the best part we can. Like that level of accreditation doesn't help us do a better job. You still, and honestly, like I think one of the big misconceptions about that ISO especially is like, it doesn't mean you do good work. It just means you keep good records.
Right. Yeah,
Like,
exactly. Yeah,
that's
you can
like,
make a million mistakes, but as long as there's an NC for every
yeah,
mistake,
you did an
you're
NCR,
good.
man, the number of horror stories I've heard is just like remarkable. But whatever, it's like when you're at a certain level, you kind of have to have it. But I don't know, it just because of the unfortunate things that have happened in the world over the last year. I can't really give you an honest appraisal on whether or not it was worth it. And we knew it wasn't going to be like the second we got it, our phones ringing off the hook with people wanting to give us work. You still got to put in the time to make sure people know about it. And like I said, it's just one more reason that people can't say no.
Oh yeah.
I recommend getting it. I know I've had some people ask who run basically like captive businesses, like they make a product. And for those like Jay Pearson Work Holding, should that guy ever get ISO? No way. He's got such a good system of how to think through work, and I don't think anybody buying from him would care if he is or not. So I don't see that that's going to help him run his business better or make a better product, right? I don't know if that's a good example or not, but
no, I think it totally is. Like like you said, you're in the job shop world. I am too. In those kind of situations, there are customers that need it. But like
yeah,
when you're
absolutely.
making your own product, like why would you? I mean, unless you're selling your own product to like medical companies or something like that, that there's a lot of reasons not to go down that path if you don't need it.
Yeah, it definitely. Again, depending on how you want to set up your manual, you can make your life absolutely miserable. So that's one thing where I think Elise spent a lot of effort was trying to make sure this is something you might actually use, but B, not have it encumber your day-to-day life in terms of just trying to, like, we don't make money for having ISO. We make money for getting parts out the door. So we don't want that to get in the way of getting parts out the door.
Yeah. I think that that's a point that's everybody I've talked to that's kind of gone through it has made, is like really nail down your processes. Like you only have to do what you wrote down, and so write down as little as possible to satisfy the requirements.
Yeah. Yeah, so
So
it's I think it's going to be a good thing overall. It doesn't affect our day to day how we operate things, and so far it hasn't been a huge addition to our customer base or revenue. But again, like you said, we got it in the fall, and the world's kind of been a shit show since then. So, or even before then. So I'm not going to give it. I'll give it another few years. Ask me the question again. Then I think we
yeah,
should have a better sense.
deal. And then the last question we had from a listener was from Easton at Moria Manufacturing. He asked thoughts on Mesotrol versus the C0 control versus your FANUC control.
I don't know. I'm not. The first machine we had, that router it runs a software on Windows called like WinCNC, which I don't know if it runs on a Mach 3 back end. I don't really know what it is behind the scenes, but that's what I learned on, and in a lot of ways it spoiled me for how simple and straightforward a CNC controller can be. Everything after that, like, mind you, it's not as powerful, but everything after that just seems like it's a vestige of a bygone time. Like the memory versus like tape that I've got on so many of the controllers, like I feel like I got more processing power in my pocket in the form of a cell phone than any of my CNC machines have, right? Like, why is it so backwards? So I'm not stuck on any single one. I'm not a fanboy of like a particular controller. I think there are features of each one that, depending on how you use it, would be preferable, like how your workflow is set up. So the Mazak is Windows based, but it really is. I'd say it's pretty similar to FANUC in a lot of ways. And then you're familiar with the C00, again, kind of similar. I think that the Mazak is based on Mitsubishi Meldis. I could be wrong about that, but I'm pretty sure like all their machines used to be Mitsubishi, and
Okay.
that changed over at some point. But yeah, like I think there would have to be like specific example questions placed of like, what do you like better? I think I mentioned it earlier. Any controller that you can put on your network and just dump your computer or your programs to right from your CAM software, even if you're not posting a lot of programs, that's a really, really nice feature. So yeah, because the Mazak is right on, like it's a Windows-based computer on the back end, I can post my files right to the tape drive on that machine. So like I walk over to the machine and they're there on the controller when I get there. Whereas the FANUC, the FANUC has a FTP. Like FANUC's got their own software. I think you can use like FileZilla to accomplish the same thing,
Mm-hmm.
just like an FTP thing. And brother had one too. Like we had the brother software to just be able to, like, we had the Ethernet connection into the machine, and I could just, you post your program onto your computer somewhere and then use that software to transfer it over. So I think a huge thing for me in our workflow and how much programming we're doing, having a controller that just lets you dump the files right onto it and not having to take extra steps, like those little things kind of add up over the day of just like nagging at you. Like the number of times I'll walk over to the machine and like hit cycle start and it's running the same program I just ran because I forgot to use the file transfer program. It's like that's kind of frustrating. But between the controllers, I don't have a strong preference. I think it depends on what you want to do. I don't know. What are the machines that you run at work?
There are a few Yasnaks, and then mostly FANUC, and then we've got one or two brothers.
Yeah. So like, do you notice a big difference between the FANUC and your brother?
I think because I have brothers in my own shop, I tend to prefer the control. like just because that's what I use the majority. But there's things that I like on each one of them. Like there's buttons that I look for that I can't do. There's a lot of things too on the brother controls that are now on newer Fanic controls that weren't on older ones. Like you on newer Fanic controls, you can flip a bit and stop it from over traveling, and it just stops when it hits the limit switch. But
Yeah.
like older Fanics, man, I our robo drills at work, I jog into the limits all the time because I'm so used to my brother where it just stops.
I've never had. I think the only time I've done that on the brother is when you got to do that like Z tool recovery when it craps out halfway through a tool change, and
Yeah,
you've
so
got to.
the brother just never over travels unless you do something wrong. But like
No, like I
the
had a couple where you've got to be holding, while you're holding like 4 or 5 different keys while you jog Z up to get it to clear, and it'll bump into the top travel there.
yeah.
So I did that, but yeah, like
Yeah.
I don't. I guess the oldest machine I have is the router, and it's coming up on 8 years old. And then after that, it's the 5-year-old um, Mazak. So like we've always bought new machines, and so that means we've got new controllers. So I don't know. I guess to your point, like how bad can get when you go back. And yeah, like what do I like about the Mazak? I like that even when you're like manually jogging around, not in a program, your Z value will read out in a meaningful, like it'll pull the tool offset, and I could never figure that out on the brother. So like if I'm 1 inch off the table and I've got an end mill in there, I know I can slip a 1 inch gauge block under there and not have to do any math or like tell the machine I'm in a certain WCS. Like the Mazak just does that automatically.
Oh, that's nice. Yeah.
Yeah, so like that, and that's the first real CNC controller I had. So then when we got the brother, and it's like, doesn't it work backwards? Like it counts up or
Yeah.
down?
Yeah.
Yeah,
0 is from the table.
like shit, man. I'm like trying to figure that out. Like, okay, now go back, add, subtract. What am I doing here? So yeah, like the Mazak is like, I don't know why all controllers aren't like that. Like it'll automatically pull the tool offset length and add it to your machine coordinate system to tell you like where you are in a meaningful manner. The I don't think the Matsura does that either. So yeah, it's just frustrating. Like having to flip back and forth to your offset page and have a calculator next to you seems super unnecessary. So
Yeah.
that's one thing I really like about the Mazak.
That makes sense.
Yeah, and then the smoothing, like I don't know, it took us a little while. Like the other thing that's not fair about assessing the Fanic on the Matsura is they have like a shitload of customized M codes. So I don't know why they do it. Like I broke a couple taps because the can cycle for tapping is a different number
Yeah, it's
and
M80.
something like that.
Yep.
Yeah.
Yeah, we've got a bunch of Matsuras at work, and they are the Matsura flavor of Fanic is its own beast for sure. Like you got the handyman stuff that you can jump into, and
And
yeah.
yeah, like we really only use that for the pallet pool. But yeah, again, like it's a little bit of it. The horizontals, I think when we got it 2 years ago, they were still had like the 31i, I think. Is that
Hmm.
right? So like it, all the other, like especially their 5-axis machines are onto the newer controller. I don't know what it is,
It's
but
like IHMIC or something. It's
yeah, it's like it
the
looks a little
Windows
sad.
based one in the background, I think.
Yeah, ours looks super old school, but it works kind of. It's like a little, yeah, you know all the frustrations if you've got them at work, but like once you get that ironed out in your post, like I'm very much like a CAD based, CAM based guy for running the machines. Like I would to be able to write any codes by hand, it would take me a really long time. I know there are some, especially like older guys who are like super proficient at that, or guys who like literally program right from the controller everything they do. I noticed that a lot on like horizontal boring mill operators, things like that.
Yeah,
Uh,
my G code teacher in school was like he came up through the ranks doing that, and then broke into CAM. But he was like, yeah, I had a little whiteboard next to my machine, and I'd tape my print up there and do any math on the whiteboard I needed, and just sit there and type it in. And I was like,
yeah,
jeez.
that's wild. There's just like even more so than what I do. There's so much room for mistake there, right? Like I just you got to be so on the ball all day that like trying to run a business on top of that. I think that works if you've got a guy who can literally just sit at the machine all day and have no distractions. But I don't know. It's not for me. It's
Yeah, me
very
neither.
error prone. So yeah, like I don't have a favorite controller. I don't know. Nothing's really blown me away. Heard good things about Heidenhain and Fidia from like 5-axis stuff, Fidia especially, but
Mhm.
I don't know too many people with firsthand experience there.
No, those are pretty boutique, and a lot of those shops that run those aren't sharing much with outsiders.
Yeah, well, I think I could be wrong about this, but I kind of think that they were originally a CNC control manufacturer, and then they got into making machine tools. And then once they started making machine tools, everyone said like, "Hey, what the hell? We're not buying your drives anymore. You're a competitor." So,
Huh.
yeah, like someone I talked to who knew, like, used to run one, said that they wished like all their machines for 5-axis work could have had that on it. But
Really?
yeah, I think so. Someone needs to fact check me on that, but
Well, cool. Well, that kind of wraps up all of our questions. I always end the episode by asking my guest, "What have you been researching this week?" I think that we all have, and it doesn't have to be machining related. It's just whatever has been high on your browser this week that you've been diving into.
yeah, like I spend a lot of time researching stuff, I guess. I watch a lot of YouTube content, and my secret there is I and your like podcast, when I listen to any of your podcasts, everything is on as fast a playback speed as the service will offer. So YouTube, it's only 2 times, but I think you can get up to 3 times on podcasts. So that's how I get through a lot of content. Is everything is double speed or triple speed when I listen or watch. Um, so that's kind of one of my tips for crushing through stuff. But yeah, I guess what I'm supposed to be researching on is like machine learning and manufacturing. So that's something that I should be devoting more time to every week, but I'm not.
What's your goal there?
That's for my PhD.
Oh, right. We didn't even talk about that. I feel bad that I didn't bring that up. So you're going real quick. I guess at the end of the show, we'll talk about that. You're going for your PhD in mechanical engineering.
That's correct. Yeah, there's a university here in town that has a pretty good like machine shop. It's called the McMaster Manufacturing Research Institute. So they do a lot of research, kind of anything in and around machining, whether that be precision machining, machine tool development, cutting tool development, coatings, things like that. So they've got a bunch of CNC equipment in there and like PVD coating labs, things like that, metrology equipment. Um,
Wow, that's amazing.
yeah, it is really cool. So I started into it a little over a year ago, last fall. I started my coursework. So studied the 2 courses I took were solidification processing. So that pretty much has to do with casting, any type of taking a liquid metal and turning it into a solid metal, covered in that class, and then machine tool analysis. So yeah, because of my background in statistics, I think the idea is that we'll be doing some machine learning on all the data that the various labs generate there. So most researchers there are collecting some form of data, and there are quite a few of them working on kind of different pockets. So you got someone studying coatings and machining a certain type of material with it. They're going to be putting all that information into a database, and is there something that we can kind of suck out of that database that's bigger than any one of those pursuits on their own? Like they might come to their own conclusions, but there could be information in there that's relevant to someone else's research and they don't even know it. So using machine learning algorithms, you're able to process a lot of that information. So
Awesome.
I'm still kind of early in the thesis portion of it. So that's kind of what I should be doing all my reading on in my free time, but it's a slow grind. I think a bit of a challenge right now while schools are not really like it's all online, so it's hard to collaborate with people.
Definitely. Yeah. Well, it's hard to analyze data that's not being created.
Oh, the data's there, but it's like I've got to be able to have a pretty good understanding about what people are working on to really um, be able to interpret their results and deal with them in a meaningful manner. So you got to know the ins and outs of their experiments, things like that. So yeah, that's one thing I'm researching. Always staying on top of like what machine tools. I troll all their all the big OEMs, their YouTube pages once or twice a week, trying to see if they posted any new things. Haas has always got new videos up, you know.
Oh yeah.
So yeah, that's yeah, that's what's on the. So yeah, I can post some specific books for reading, but they're pretty esoteric.
Well, I've seen them pop up in your feed a few times, and I'm always like, man, that would be great if I had extra time to read that. Like, it is very niche, but it is all of them look really cool always.
Yeah, like there's usually some tidbits in them. Interesting amount of overlap on some of the books for some of the other Instagrammers have posted. So like Renzetti put up after your podcast a pretty good list of books.
Yeah, I still need to get some of those and work through them. I just need to find some more time to read.
Yeah, well, it all depends, right? Like just getting a book and reading it. Like sometimes you can learn a lot of stuff just by doing things. Or I really like YouTube videos for that. You know, you can get in the way that a picture's worth 1,000 words. I think a video sometimes is whatever order of magnitude beyond that. Like I'll spend a lot of time watching YouTube videos that seem irrelevant just to see if there's some little thing happening in the background that you can kind of pick up on.
Oh, totally. Yeah, and those little tidbits usually make the time investment worth it alone. So I totally agree.
Yeah, especially on double time.
Yeah. Awesome. Well, hey, thanks, Jonathan, for joining me on the podcast. I really appreciate it. It was great to get to talk to you and learn more. I've been following you, I think, for a few years now, and so it's really cool to hear your whole story and how you guys came to be.
I appreciate it. I don't know that I'll listen to this podcast because I'll probably cringe at the sound of my own voice, but be happy to do any follow up.
Yeah, I'd love to have you back on. We can check in on that AS9100 certification and how it's doing for you in a couple months or something like that. And thank you again.
Yeah, keep the questions coming. When appreciate that you follow us.
Definitely. Well, thanks guys for joining us. We will be back next week, and a little update on the book club. We are going to stop on Traction right now, and in a couple weeks, the new way we're going to do it is we're going to read through the entire book and then have somebody come on and talk about the entire book. And so in a couple weeks, we have AJ from Design the Everything coming on to discuss The Purple Cow by Seth Godin. So go ahead and pick that up and start reading through it, and we will discuss it in a couple weeks. Thanks again, Jonathan.